Hello and welcome to another video from the lecture series entitled Advanced Biomaterials. So in today's video we'll be looking at ceramics. Ceramics as a class of important types of biomaterials. So what are ceramics? Now these ceramics are defined, or the ceramics are known as a class of biomaterials which are inorganic or non-metallic in nature. So these are a class of biomaterials which are inorganic or non-metallic. Inorganic or non-metallic. So now these what are bioceramics? So obviously these ceramic materials which can be used directly in association with biological systems, or they can be used to mimic or to be used in vivo with biological systems to mimic certain structure, function, properties of an innate material with which they are associated with, or they are intended to be associated with. These materials are known as bioceramics. So these bioceramics are now defined as natural or synthetic materials which are suitable for introduction into living tissue, especially as a part of a medical device. So these bioceramics are materials which are suitable for introduction inside living tissues as part of medical devices. So these are also a class of ceramic materials which can be used in close association with living tissues. So now these bioceramics, as we have just mentioned, that these can be natural or synthetic in its origin on basis of its classification. Now there can be other modes of classification as well. So one of the very important classification systems of these bioceramics based on their activity or based on their mode of action or their action inside living systems are so these bioceramics can be classified as inert, bioactive, and bioresorbable or biodegradable. So inert, bioactive, and biodegradable. So all these materials are essentially solid and inorganic compounds with various types of or various combinations of ionic or covalent bondings. So all these ceramic materials which are chemically inorganic, usually inorganic compounds which with different types of combinations of ionic or covalent interactions. So now what are these inert, bioactive and biodegradable classes or classification of ceramics? Now bio-inert ceramics essentially imply that these ceramics do not play any active association or active interaction to play with living tissues or living cells inside biological systems. So that is why, because of the inert nature and non-association with living tissues or living cells, these are called as bio-inert ceramics. So these are able to maintain their physical and mechanical properties while inside host tissues. These bioceramics or inert classification of bioceramics are very corrosion resistant because of their inert nature. So they show high resistance to wear and corrosion, which is also an essential property which is quite unique for ceramic materials. So these inert materials have also been reported to possess a high fracture toughness, right? And also they are typically used to structure support implants such as bone plates, bone screw and femoral heads. So these are mainly used for hip joint arthroplasties. So joint prepared. Now coming to bioactive. So bioactive ceramics. Now bioactive, as the name implies, they are intended to show some strong association with living cells or living tissues in biosystems. So direct and strong interaction with living tissue, like the fixation of implants in skeletal systems. So since in skeletal system if you are trying to fix certain implants, so these implants will be required to show some interaction with the living tissue such as the muscle tissue, to hold them, to support their mechanical functions or mechanical properties, mimic their properties. So these bioactive class of ceramics will show some degree of a strong association or interaction with living tissues. But these materials, if they are trying to mimic certain soft tissues, so these usually have lower mechanical strength and fracture toughness compared to the other classifications. Now the certain examples of these ceramics can be the glass ceramics and dense non-porous glasses. Now coming to the third one, which is very important in consideration for many biological or biomedical applications, are the biodegradable or the bioresorbable ceramics. So what is the meaning of the term biodegradable? Biodegradable means that the material which is used inside or in conjunction with living tissues can be broken down or degraded or even resolved inside the system with the help of certain enzymes or certain degrading components inside the living system. So biodegradable means that the material can be degraded using certain biological components or biological systems. So chemically these can be broken down and degraded by the body. Now the resorbed material is replaced by the exogenous tissue. So this is an important consideration of biodegradable or bioresorbable ceramics. So as soon as the original material starts degrading or starts resolving, so the degraded material or the lost material is actually replaced or restored by the natural exogenous tissue present in the body. So the chemicals produced as the ceramics reabsorb definitely must be able to process through the normal metabolic pathways of the body without without having any deleterious effect. So the degraded products need to be biocompatible, need to be highly safe for the biological system in which they are being used. So these properties are important for for this biodegradable class of ceramics. So now also these ceramics can be classified as natural and synthetic because they can be synthesized from both natural as well as synthetic sources. So let's look at some of the examples of these inert type of these bioceramics. So the inert class examples would include alumina, which is aluminium oxide Al2O3. Then there is zirconia, which is ZrO2. Then the examples of these bioactive ceramics would essentially include the different glasses such as bioglass, and finally the biodegradable or the bioresorbable ceramics would include the hydroxyapatite, which is a very important material which is used for making different fabrication materials using these ceramics. so such as scaffolds for tissue repair. So this hydroxyapatite, this formula is calcium 10 phosphate 6 and hydroxy 2. So this is the structure of hydroxyapatite, and also there is another example which is tricalcium phosphate. Right. So these were the examples of the some of the important ceramics. Now, what are the characteristics of these ceramics which makes them different from other types of biomaterials? So let's look at some of the characteristics. So let me erase out some of this part. So some of these characteristics of these ceramics which makes them quite different from other classes of biomaterials are: the first one is they show the property of significant hardness. So extreme hardness. Because they show this property of extreme hardness, they show high resistance to wear and friction. Because of their surface hardness, these ceramics are used in the coating of materials which are subjected to high degrees of friction. So friction would produce heat and would produce wear and tear. But because of their high inert hardness, these ceramic materials are used in certain applications where material or component fabrication is required, which are subjected to high wear and tear. Because of their extreme hardness, they would show high this resistance to wear and friction, wear due to friction. So then they also show this property of high resistance to heat. Now, because these ceramic materials are heat resistance or property of thermal resistance, these can be used for materials which can actually withstand temperature fluctuations or temperature changes. So these show the property of resistance to heat as well. Then another important property of these ceramics are that because they show resistance to heat, they have a low thermal conductivity. Low heat conductivity are a property of the ceramic materials. That is why the cups which we use for drinking hot drinks or teas, they are made up of ceramic materials. Another interesting property is that they also show low electrical conductivity. Ceramic materials also have because they show low thermal conductivity, they also have low thermal expansion as well. So upon heating, upon subject to heat, the ceramic materials, unlike the metals, they do not expand. They do not expand in volume. They retain their original volume. Therefore, so because they have this low thermal expansion coefficient, and also they have poor thermal shock resistance. So they have low thermal expansion and show poor thermal shock resistance. Now these were some of the important characteristics of ceramic materials. So these ceramic materials have properties or characteristics which are quite different from that of metals and polymers, which are other important classes of biomaterials. So because of these different or unique characteristics, they have unique applications as well, or applications in which these metals or polymeric systems would fail, these ceramic systems would prevail. So what are some of the important applications of ceramics in the biomedical and the therapeutic sector? So now we'll look at the applications of these ceramic materials. So the important applications of these ceramics include the most important orthopedic load bearing implants. So these orthopedic implants, which are used to mimic the properties of bones, all these materials are now made up of ceramics. So ceramics would include this alumina L2O3. These orthopedic load bearing implants would include the implants for total hip arthroplasties, then the knee replacement surgeries. So all these materials would be essentially be made up of ceramics. The other interesting application would be so the different types of coatings. So all the different types of coatings which were made up of these ceramic material, these to show a high degree of resistance to wear and corrosion because of friction. So all these different types of coatings which are subjected to this active stress cycle or active wear and tear and active corrosion. So all these types of coatings are made up of ceramics because they have this property of high resistance to wear and tear. Then there is another interesting application, that is these dental implants. So examples of the different types of surface coatings would include the hydroxyapatite surface active glasses and the different types of glass ceramics. So all these are used for surface coatings. Now coming to the dental implants. So different types of dental implants which mimic the properties of teeth are used from different ceramic materials such as this hydroxyapatite and even alumina. Now also these ceramics are used as temporary bone fillers. So bone space fillers. So these bone space fillers would include materials such as which mimic the properties of bone tissue. So these include the trisodium phosphates and the calcium phosphate salts. So and also now, as we have seen that in order to fabricate materials with very tunable properties based on a very specific application or a very specific tissue type whose function or whose structure we are trying to mimic, so we can do what is known as making composites with other types of materials. So even these ceramics can be made into composites with other types of materials. So these composites would include these composites would include the artificial tendons and ligaments, which are made up of polymers, PLA and carbon fiber composites. So these are ceramic materials can be used in combination with polymers and carbon fiber materials to give rise to the properties of artificial tendons and ligaments. Now, let's all these ceramics were some of the artificial systems in which they are found as non-naturally. Let's look at some of the examples of natural ceramics, naturally occurring ceramics. Now, calcium carbonate is a very interesting material because it is widely distributed over the biosphere in the presence of in different, and its presence is noted in different living components as well. So these mollusk shells, the shells of mollusks, show the shells of the different types of snails. These are made up of calcium carbonate. And this organic layer which they have is made up of CONCHIOLIN, a compound, conchyolin, and perlucin. So this is the organic layer of the shells. And also, in our body, the most abundant reserve of ceramic materials are our bone tissue. So the second example is bone tissue. So these are made up of this calcium hydroxyapatites, HAP, which is calcium 10 phosphate 6 and OH2. Now these hydroxyapatite materials are used for fabricating a wide range of scaffolds with different properties, and also they can be made into composites with other types of materials. So these are used for making bioceramic scaffolds for supporting the repair or regeneration of bone tissues. So all these examples, these properties of these ceramic materials makes them quite interesting candidates for their role in different types of applications in this biomedical engineering and tissue engineering. So now there is also lot of research which is being focused into this type of biomaterial for making novel composites with which can achieve very desirable properties which can closely mimic to that of very specific biological systems. So these ceramics are a very essential or a very important field of research into these advanced biomaterials. So that will be all for today's video. Hope you enjoyed it. See you in the next video. Till then, thank you.